Grade 10s, welcome to Lesson 4 of Week 17, Life Sciences. This week, we're focusing on the rate of transpiration, and when we refer to the rate, we mean the speed at which transpiration will take place. Previously, we said there are 4 environmental factors that affect the rate of transpiration. We've looked so far at temperature, light intensity, and today we're looking at wind. Wind is an increase in the movement of air past something. You know that it is windy if you see things blowing in the wind, and the wind is simply an increase in the number of air currents or the air moving past something. Now, the situation that we have is a plant, and it's photosynthesizing, and therefore it requires water. Water is also produced by the process of cellular respiration, and therefore water is a feature of the leaves of this plant. But the plant loses water vapor from the stomata, and that is precisely the process of transpiration. Now, if we were to increase the wind or the air currents past this plant or over this plant, what would we do to the rate of transpiration? Can you predict what would happen with an increase of air currents or an increase in wind? What would happen to the rate of transpiration? This is very much a simplified diagram of what we could expect to see on the underside of a leaf. We would find all these little stomata, and out of the stomata we would find water vapor evaporating. Now, as the water vapor evaporates, it of course stays in the air around the leaf. The mechanism that is driving this evaporation is a difference in water potential. We know that inside the leaf, the water potential is high. Outside the leaf, the water potential is low. This means that the water will move from a high water potential or an area of high water potential to an area of low water potential. And this is the mechanism that drives the diffusion or evaporation of water vapor from the leaf to outside in the environment. Now, if we were to introduce wind, the air currents would increase past the leaf and would blow this evaporated water vapor away. The effect here would be to greatly increase the difference in water potential. Now, instead of just having a high water potential and a low water potential, we would have a high water potential and a very low water potential, because as the water evaporated to the outside of the leaf, it would be immediately blown away by the wind, which would lower the water potential even further. So, let's get back to our original question. What is going to happen to the rate of transpiration if we increase the wind? Can you see that you're going to also increase the rate of transpiration? Remember our useful piece of equipment that is used to measure the rate of transpiration, the pedometer. We could test this suggestion that increases in wind will result in an increase in the rate of transpiration. And of course, we could set up our pedometer. And if you've forgotten how the pedometer is set up, you need to go back to lesson 2 of week 17, where we explained this in detail. The pedometer then would show us, we would establish the normal rate of transpiration. Let's say it was that the air bubble moved 1 centimeter per minute. We would then put a fan next to the plant, and the fan would blow the air currents over the plant, and this of course would simulate or copy wind in the environment. What would happen to the rate of transpiration? We would see that we would have an air bubble that moved much faster, and we would see that there's an increase in the rate of transpiration with an increase in wind. Here is your homework. What are the environmental conditions that would give us the highest transpiration rate and the lowest transpiration rate?